Hi dear students and viewers, welcome back to our channel Anvane Kumar Basics of Physics. This is the right place to learn. Dear students, in this video we are going to discuss about one of the most important topic, that is working of Carnot engine or Carnot cycle. So before going to that, you have to know about the reversible process and irreversible process. So dear students, this is the most important for 8 marks question in public examination point of view, and not only for public examinations, and it is very important for competitive exams. So that's why watch the video up to last without any skip. So now coming to the point, first we have to know about what is reversible process. The process which is going through the so many stages, and after that again that should be retraced back to the initial stage, and that should be passes through the same steps. Clear? The process which can be moving through the so many stages and finally reaches the one particular stage. From that stage to the again that should reaches the initial stage, in which steps it is going, in the same steps that should be comes back. That process what we call reversible process. For example, here look, now one process is there. The initial stage is, I am saying now, thermodynamic variables like pressure, volume and temperature. This is the initial stage. And next one, P2, V2, T2. This is the second step or second stage. And it is P3, V3, T3. And third stage, P4, V4, T4. Clear? Stage 1, stage 2, stage 3, stage 4. Clear? The process going from stage 1 to stage 4 like this. That should be passing from P1, V1, T1 to P2, V2, T2. And P3, V3, T3. And next one is P4, V4, T4. The process is going through these steps. Again after that, the should be again comes to the same P1, V1, T1 through the same stages. The type of process called reversible process. Reversible process. Clear? The process which can goes through the different stages, and that should be again comes back to the initial stage. How? Through which steps it is going, again that becomes like that in the same stages. So already in previous videos we discussed about the cycle process. So there is some difference between cyclic process and reversible process. Cyclic process and reversible process. Clear now? This is the stage 1, stage 2, stage 3, stage 4. It is goes like this. Clear? So in cyclic process, that is directly comes to the initial stage P1, V1, T1. So you have to know about the idea about the difference between reversible process and cyclic process. In reversible process, in which steps that is going, again in the same steps that will be comes back. That is what we call reversible process. But in a cyclic process, it is passes through so many steps, but it does not follows the retrace back. In which steps it is going, in the same step it is not comes back, but that should be reaches the initial stage like this. So this is the cyclic process. So first you have no idea about the reversible process and cyclic process. So dear students, here reversible process. Example for that. Examples for reversible process. So those are, the first thing is the isothermal process, which are going through the isothermal process, and adiabatic process. If they can go in a very slow process, that means here isothermal and adiabatic process will take very slow, then those should be taken as the example for reversible process. And next example is, children, here fusion of ice, or vaporization of water. So all of you know what it is. It is the ice. If you can give the heat, that should be turned into the water. Again, if you can give the heat to the water, that will turns into the vapor. Ice, solid, and water, liquid state, and this is the vapor, gaseous state. Clear? So to convert from ice to water, for example, we are saying now 80 joules it is given. When it is 80 joules given to the ice, that should be melts water. And if we can remove the 80 joules from the water, that is turned into the ice. So ice is turned into water and water is turned into the ice. So in which steps it is going, that comes back again. And to convert the water to the vapor, for example, we are giving some 80 joules of heat, or 100, whatever maybe. Then obviously it is turned into the vapor. If we can remove the heat from the vapor by the same amount, that will use the water. That's why what you have to say, fusion of ice and vaporization of water are taken as the example for reversible process. And third one, children, here, so Peltier effect and Seebeck effect. Peltier effect and Seebeck effect, these are the examples for reversible process. What is meant by irreversible process? When a system is passing through the different stages, if it is not retraced back, that process what we call irreversible process. So here the system is passing through the like P1, V1, T1, and P2, V2 next stage, and P3, V3, T3, and P4, V4, T4. Different stages are like this. So it is initially going like this: P1, V1, T1 to P2, V2, T2, next P3, V3, T3, next P4, V4, T4, like that. So if while this comes in reverse direction, it is not coming in the same path. 1, 2, 3, 4. Initially it is going through the 1, 2, 3, 4, but while in the reverse process it does not takes place. That's why it is called irreversible process. That means the system which is passes through the number of stages, but while it comes back, it is not exactly comes in the same direction when it is going in the first time. That type what is called irreversible process. So children, there are some examples are there. Work done against the friction. Work done against the friction is the one of the example for irreversible process. And next one is the heat is produced in a conductor when the current is passing through it. Heat is produced in a conductor when the current is passing through it. This is another example for irreversible process. And third one is the diffusion of gases. So when different type of gases are combined together, it is sometimes it is not possible to get the exactly to separate them. That's why here diffusion of gas is the one of the example for irreversible process. So children, this is about the reversible and irreversible process and their examples. Now let's go for Carnot cycle working. Let's go for that, the most important. What is Carnot engine? Carnot engine is nothing but a heat engine that can be operated at two temperatures. In reversible process, that is what we call Carnot engine. Clear? I already explained what is heat engine and what is refrigerator, how they can work in previous videos. That's why you have to check the playlist. Clear? The heat engine that should be operated between two temperatures in reversible process, that is what we call Carnot cycle or Carnot engine. So in Carnot engine, ideal gas should be taken as the working substance. Clear? So the working substance is what? Ideal gas. Ideal gas is going to be under different expansions, and how they can take place and what is the efficiency of Carnot engine we will discuss here. To understand that, here there is one graph, it is there between the pressure and volume, and here there is one graph, it is there. In that graph we are showing some stages. P1 V1 T1 is the first stage and P2 V2 T1 is the next stage. Here P1 V1 T1, P2 V2 T1. So that's why here P1 V1 T1 to P2 V2 T1 is isothermal expansion. What is isothermal expansion? What is meant by isothermal process? The process in which temperature remains constant even though pressure and volume are changes, that is what we call isothermal process. If the molecule, the gas can be expanded, that is the isothermal process. Isothermal expansion, okay. And if the gas molecules comes close by maintaining some temperature is constant, that is the isothermal compression. Clear? That's why here in case of isothermal expansion, here we are showing that T1 and T1, that's why here the temperature remains constant. So we are showing P1 V1 T1 and P2 V2 T1. And next thing is here P2 V2 T1 and P3 V3 T2, P2 V2 T1 and what it is children? P3 V3 T2, P3 V3 T2. That is the adiabatic expansion. If the expansion suddenly takes place, that is what I have to say, adiabatic expansion. And now in that A dot E means what? Adiabatic expansion. And now here P3 V3 T2 to P4 V4, this is T2 children, P4 V4 T2. This is now here isothermal compression. That's why we are showing here simply this is the T2 and this is also T2. Here what it is? P3 V3 T2 means what here? P3 V3 T2 to P4 V4 T2 what is? Isothermal compression. And similarly here now, compression. And similarly here P4 V4 T2 to the P1 V1 T2 is what? Adiabatic compression. That's why here you have to first understand this diagram, then only the derivation is possible. From P1 V1 T1 to P2 V2 T1 is what? Isothermal expansion. And P2 V2 T1 to P3 V3 T2 is what? Adiabatic expansion. And P3 V3 T2 to P4 V4 T2 isocompression. Okay. Now P4 V4 T2 to the P1 V1 T1 is what? Adiabatic compression. That means here simply how to understand this entire Carnot engine is operating at the temperatures now T1 and T2. Clear? So dear students, this is simply about the diagram, and now we have to find out the work done by the ideal gas. In all these process. So for that you have to simply have idea about the two equations. One is the work done by the gas in isothermal process and work done by the gas in adiabatic process. You have to know about that one. So children, for the first process, what is P1 V1 T1 to the P2 V2 T1? That is what? Isothermal expansion. There is some work done, it is there. That should be taken as W1 is equals to nRT1 and log of V2 by V1. That means here this amount of work done nothing but equals to the amount of heat absorbed by the gas. from source. So therefore write W1 is equals to Q1 is equals to nRT1 log of V2 by V1. This is the first step. Work done by the ideal gas, that is what heat absorbed by the gas from the source. How much this one? W1 is equals to Q1 of this one. And now in the second step, what it is? Adiabatic process, adiabatic expansion. For that, in that case, the amount of work done is nothing but here nR by gamma minus 1 of temperature change from T1 to T2 minus. Therefore T2 minus T1. This is the what? Work done in adiabatic expansion. Work done by the gas in adiabatic expansion. And now in isothermal compression, that is what W3 is equals to here nR of, in that one, what is the temperature here? T2 is the temperature. Here initially in isothermal expansion, what is the temperature? T1. That's what you wrote. W1 nRT1. Here what is N? Number of moles of ideal gas. What is our universal gas constant? And what is T1? Initial temperature of the cycle. And now here T2 is the temperature is, instead of T1 here what you write? nRT2. And there should be here log of here volume change from where to where here? V4, V3. That's what I write. This is V4 by V3. We can write this equation number 3. Now this, in this case there is some work done by the gas. Work done by gas is equals to heat rejected to the sink. That means what? W3 is equals to Q2 of Q2 is equals to nRT2 log E V4 by V3. This is equation number 4, children. Clear? So this is the equation number 1 and it is 2 and now it is 3. Or simply you can take this is now 3. No problem. So this is what about the work done in isothermal compression. Now here in this case, children, I need some space, that's why I'm writing this one. In adiabatic expansion, what we have? W2 is equals to nR by gamma minus 1 of T2 minus T1. Now in case of adiabatic compression, expression, the work done should be written as here nR by gamma minus 1 of here T2 to T1. That's what right here T1 minus T2. So this is the equation number 4, children. Clear? So that's why here when we have idea about these 4 equations, then we can find out the total work done by the ideal gas in isothermal expansion, adiabatic expansion, and isothermal compression and adiabatic compression. For that we have to add all these 4 equations, Then let's go further. Here we have to add them, then we have to check what we get. Clear, children? So children, you have to watch the video very carefully. If you want to note the notes, just pause the video and write the notes. So children, for total work done, what did children here? We have to add the 4 equations. W is equals to W1 minus W1 plus W2 plus W3 plus W4. Then W is equals to, here what is W1? Yes, nRT1 log E V2 by V1 plus, and this is like this, nR by gamma minus 1 and T2 minus T1 plus what is nR, yes, what it is here, children? nRT2 log of V4 by V3 plus, now children, here already what is there here? W4 is what? Nr by gamma minus 1 of d1 minus t2. So same equation can be written as Nr by gamma minus 1 of, here I am going to write like this, t2 minus t1. Then what you get here? Minus we will get. Minus we will get. That's why here simply instead of this equation I am going to this one. What is? Minus of Nr by gamma minus 1 of t2 minus t1. Clear? So children, here this one is cancelled. Then what do you write? W is equals to here nRT1 log of V2 by V1 plus log of V4 by V3. Sorry, nRT2. Okay, once again. nRT2 log of V4 by V3. This is what? Total work done, children. So now we want to find out the efficiency of Carnot engine. Let's go for that. Here, this is the total work done, and now already we have idea about this is isothermal expansion, adiabatic expansion, axial compression, adiabatic compression. So children, here P2 V2 T1 to P3 V3 T2, that is what? Adiabatic expansion. In the adiabatic process we can have formula is like this: T1 V1 to power of gamma minus 1. Here T1 and this is what? V2. What it is? V2. So T1 V2 power of gamma minus 1 is equals to, here we will write T2 V3 gamma minus 1. It is the condition in the adiabatic process. According to what, right? T1 V2 power of gamma minus 1. Here T1 is there, V2 is there. So T1 V2 power of gamma minus 1. Here T2 it is there, V3 it is there. That's why what to write? T2 V3 power of gamma minus 1. From that what, right, children? T1 by T2 is equals to what, right? V3 by V2 gamma minus 1. Simply what, right? T1 by T2 is equals to V3 by V2 whole to the power of gamma minus 1. This is the equation number 5, children. Now similarly here P4 V4 T2 to the P1 V1 T1 is what? Adiabatic compression. So here P4 V4 T2 to the P1 V1 T1, that is what? Adiabatic compression, nothing but adiabatic process. Then what we write here? V4 or simply T2 into V2 power of gamma minus 1 is equals to, here T1 of V1 to power of gamma minus 1. From that what, right, children? T1 by T2 is equals to what, right? V4 by V1 whole to the power of gamma minus 1. This is equation number 6. Clear, children? So this is the gamma minus 1. So T1 by T2, you have to observe the equation number 5 and 6. T1 by T2, LS are equal. Then what, right? V3 by V2 from equations 5 and 6. We can write V3 by V2 whole to the power of gamma minus 1. Whole to the power of gamma minus 1 is equals to V4 by V1 whole to the power of gamma minus 1. Here gamma minus 1 cancel. Then what it gets here? V3 by V4. So from the dot, right, here simply V3 by V2 is equals to V4 by V1. From that we can write V1 by V2 is equals to S. V3 by V4 is equals to V2 by V1. So why we are doing all these things means, let's go further here. So this equation number now 7. So children, we have efficiency formula is there, that is nothing but here efficiency of Carnot is nothing but it is W by Q1. Nida is equals to W by Q1. What is W? Amount of work, total work done by the amount of heat taken from the source. So W by Q1. Here neta is equals to W means what here? nRT1 of log of V2 by V1. And this should be written as children nRT2 log of V3 by V4 we can write. Clear? So nRT2 log V4 by V3 can be written as minus of nRT2 by log of V3 by V4 by, already we discussed this one Q1. What is Q1? This one nRT1 log of V2 by V1. Clear? So from that what right children here? Very simple. These two are going to be cancelled. Then we can write like this. What is neta is equals to nRT1 log V2 by V1 divided by nRT1 log of V2 by V1 minus what is it children? nRT2 log V3 by V4 by nRT1 log V2 by V1. So children, these two are cancelled. NR cancel, RR cancel. Clear? Then what do you get? Neta is equals to 1 minus of T2 by T1 of log V3 by V4 by log V2 by V1. So already we proved children what is V2 by V1 is equals to V3 by V4 we proved. Already just go for 10 to 20 seconds back, you will find this one. V2 by V1 is V3 by V4. That's why these two are cancelled. Then what rate? Neta is equals to 1 minus T2 by T1. So children, this is the what it is efficiency of Carnot engine. Efficiency of Carnot engine. Here T1 is the source temperature and T2 is the sink temperature. That's why from this formula what you have to say, Carnot engine can be operated between two temperatures. So children, this is the derivation to find out the efficiency of Carnot cycle in our first year physics. This is the very useful derivation. If you can understand this one, like, share, comment the video and subscribe my channel to get the all notifications. Okay, thank you for watching.